Okay, let's talk about section 1.7, problem solving. In this section, we will have a lot of word problems, like applied problems. Those problems usually does not come with x, y, z, t, whatever variables. They will provide a story, and you're going to understand the story and get abstract constants or abstract variable from the story and solve the problem in the story. Okay, so let's see. Uh, the first part of this section says translate verbal descriptions, translate the story, verbal descriptions into mathematical expressions. So in this first part, the author listed some verbal descriptions and try to write down the corresponding mathematical expression. Okay, so for example, in this example, they list first one. So for uniform motion. What is a uniform motion? Uniform motion means something either stops, don't the stuff does not move, or something moves with the same speed and same direction. Nothing changes, just keep moving. Okay, so the uniform motion, like the constant speed, then it's described the constant speed of an object equals the distance traveled divided by the time required. Okay, so this is a like description about the uniform motion. Uniform motion, then you will have three concepts. One is the distance traveled, the one is the time required, the other one is the speed. Okay, so that's a story. There's no variable, just words. And if we are talking about mathematics, mathematical expression, let r be the speed, d be the distance, because you know that for different object under different condition, the speed may be different. So speed should be a variable, should change. And distance, of course, you travel long time, the distance will be long. You travel short time, distance is short. So distance is also changing, and time, of course, changes. And t be the time, t be the time. Then this uniform motion constant speed equals, so what's the speed? R. R equals distance divided time. So that this one is the corresponding mathematical expression. So usually when you notice that something is a variable, something is always changing, even though here it says constant speed, this constant come from the previous stuff, uniform motion, but speed of the object always changes, right? Not always changes. For different object, the speed will be different. So it's not the universal constant. Okay, and then they gave the relation equals the distance divided by the time. distance divided by the time. So that's the mathematical expression. Okay, and second part, let x denote a number. So we have a number. We don't know what the value of the number. And then the number 5 times as larger as x. The number 5 times as large as x. Number 5 times as large as x is 5x. That's like the verbal description. What does it mean? 5 times as large as x. It's like you learn a language. You have to understand that this language means 5 times x. The number 3 less than x. It's a 3 less than x is x minus 3. Remove 3, it is equal, right? The number that exceeds x by 4, exceeds x by 4, bigger than x by 4 is x plus 4. Exceed x, add x by 4. And the number that, not here, that and here, 1 added to x, added to x gives 5. Okay, so you have a number, add to x is equal to 5. So another number plus x is 5. Then the number should be 5 minus x. Right? Additional number plus x is 5. That additional number is 5 minus x. All right? So that's how the language describe the relation. But you can see that the language sometimes is not extremely clear. You must understand the meaning, and then you know what it is. But for the mathematical expression, it's always straightforward, right? Okay, so those two are the examples of translation from verbal descriptions to mathematical expressions. You should be able to do such translation. And in the rest of the sections, we will see all kinds of translations. We're trying to translate verbal problems. Okay? Second part, interest problem. We're talking about interest. We're going to put money in the bank or borrow money or lend money. Okay? So we all know what interest means. You put money in the bank will pay you the interest because the bank will use your money to make profit, right? So that's interest. Then the money you deposit, you put in the bank is called the principal, right? So you have money, you put it to the bank, then it's called the principal. And the bank will give you interest as long as you still keep your money in the bank, give you the interest. And the interest, of course, it depends on the principal. If you just put a bank like $1, you possibly will have almost zero interest. But if you put like $10,000 in the bank, you have more interest. So interest depends on the principal, and interest actually is a proportional it's a proportional to the principal. It's more or less like, it's usually is like some number times the principal. Like for example, you will get 0.1% of interest based on your principal. 0.1%, 0.1%, or higher 1%. Like every year you will get, if you deposit $100, you will get $1 out of the as interest if you have a 1%, right? So this is called the rate of interest. Rate of interest. Of course, we want the rate as high as possible, but usually that's impossible. Okay. Okay. So let's see. This is interest problem. Now there is a general formula. It's called the simple interest formula. What is a simple interest formula? If a principal of $P is borrowed for a period of T years, like you put some $P in the bank for like 5 years or 10 years, like, right, at a per annum per year interest rate R. So that every year they will give you certain interest. That interest rate, year interest rate, expressed as a decimal. Then you are going to, you can compute the total interest you can earn after T years. The interest I charged is equal to the principal times interest rate. Like 1 year you will get such amount of interest, and then times T, like 2 years you double it, 3 years you triple it, and with T years you just multiply it by T. So this PRT, the product will give you the amount of the interest charged based on this formula. And if we have such formula, this interest is called simple interest. Simple interest, you just get simple product, simple interest, okay? When we use this formula, we will possibly not use 0.1%. We will directly use 0.001. This is a decimal. You can easily do the product. Okay? Okay, good. Let's see the examples. Yes. So suppose that Juanita borrows $500 for 6 months. For 6 months at the simple interest rate of 9%. Well, it's very high per annum. Okay. what is the interest that Juanita will be charged on the loan? How much does Juanita owe after 6 months? Okay. So it's our first example. We have a person who borrows $500 for 6 months with the interest rate 9% per annum, and they want to know what is interest charged on the loan and how much Juanita owe after 6 months. So let's check. What is P? P is $500. What is R? Interest rate is 9%. Remember, we want decimal, it's 0.09. Okay, decimal 9% is 0.09. And what is a T? T, remember here in the formula, T has a unit years, T years. But here you have 6 months. 6 months is 0.5 years, so T is 0.5. Okay, and then what is interest? Interest is 500 times 0.09 and times T, half. Okay, so what this is? Well, let's see. 500 times 0.9. These two zero cancelled with this 0.09, and so you see 5 times 100 times 0.09 times 0.5. 100 times 0.09 is 9. 5 times 9 times 0.5. It's 45 times 0.5 is 22.5. So it's $22.5. Okay? So you can answer that Juanita will be charged $22.5. Okay, this is interest. And how much does Juanita owe after 6 months? So after 6 months, Juanita has to actually owe means you have to pay back $500 plus interest. So it's $522.5 after 6 months, right? So this is O means you have to include the principal together with the interest. Okay, so that's our first interest problem. Okay. And second problem, let's see the investment. Okay, Candy. Candy has $70,000. She's very rich to invest and wants an annual return of $2,800. Okay, annual return. And this return compared with $70,000, which requires an overall rate of return. Rate of return is just rate of the earning, right? 4%. You check that 4% times this $70,000 is exactly this $2,800. So this number over 70 is this 4%. Okay, so this is what she wants, and the rest of them will be how she make it happen. So she can invest in a safe government insured certificate of deposit, CD, certificate deposit, but it only pays 2%. So she wants 4%, but now it's just 2%, so it's pay less. The government insured certificate of deposit does not give her enough back return, right? Okay, so to obtain 4%, she agrees to invest some of her money in non-insured corporate bonds. Corporate bonds. Because it's non-insured, sometimes you may lose them. But if you earn, you will get a high feedback. So they're paying 7%. How much should be placed in each investment? Okay, so we want 4%, and now we want to see how can we divide the investment to get the goal. Okay. We don't know the amount of money invested to CD and the amount of money invested to the non-insured corporate bond. So we just assume she puts X dollars in CD, certificates of deposit. If she puts X dollars in CD, then she will put 70,000 minus X dollars in corporate bonds, right? We have this amount of money in here and the rest of the money in the other place. Okay, then what is her goal? Her goal is to earn $2,800. CD will give you 2%. 2% times the principal. That's the return. And the 70,000 minus X times 7%. This is the earning from the non-insured corporate bonds, right? This principal times the rate. And together, they should meet the goal 2,800, right? So that's it. That's a condition. So let's try to solve it. So 2% is 0.02x. 7%. Sorry. Yeah. 7% is a 0.07. And well, let's do the computation. So it's a 0.02x plus 70,000 times 0.07 is 4900. Okay, how do I get it? You remove those two zero, you cancel. In order to cancel these two zero, you need to balance these two zero. Okay, 100 times 0.01 is 1. So it looks like you balance these two zero with these two zero. Okay, so they are cancelled. You will have 700 times 7 is that's why you get 4,900 and minus 0.07x. Okay, so it's a 4900. 0.02 minus 0.07 is minus. Okay, and then you're going to move to 2800 to the left, 0.05x to the right. Okay, so this becomes, what is this? It's $2,100, 0.05. And then we're going to divide the two sides by 0.05. Okay, remember, divide this always by the coefficient of x. So you will get x is, okay, so you multiply it by 100, get 5, and you divide this by 5. You move two units, so you make up two zeros above, and divide by 5, you got $42,000. So x is $42,000. X is the amount of the money put in the CD. So she should invest $42,000 in CD, and the rest of the money is 70,000 minus 42,000, and what's that? It's $28,000 in bonds. Okay, that's it. That is a simple interest problem. Simple interest problem. Okay. Okay, so third part, solve a mixture problem. Mixture problem. Actually, this second interest problem is a mixture because she has some insured CD plus non-insured corporate bonds. She has to mix them together to get the goal, right? And problem 3 is also a mixture problem, but it's not the mixture of the money. It's a mixture of the material. Let's see the example, we will understand it. The manager of a Starbucks, whatever, of a store. I'm not going to try to copy them all the time. A manager of the store decides to experiment with a new blend mixture, new blend of coffee. Okay, they want to mix coffees. Here they want to mix monies. She will put mix some B grade like the CD with a lower interest rate. B grade coffee. That B grade, how expensive, how much it sells. That sells for $5 per pound. This is B grade. It's like that 2%. Weighs some A grade coffee. It's like that corporate bond that sells for $10 per pound. Okay, so they are going to mix A grade, B grade together to get 100 pound. 100 pound is like that $70,000. 100 pounds of new blend, of the new blend. The selling price is to be $7. Selling price is to be $7. It's like that 4%. Okay. And there's no difference in revenue from selling new brand versus selling other types. Okay, so I'm not going to copy it, just to say it. Basically, this means if you do not mix them, you sell one by one, you get the money is the same as you sell this blend, new blend, you get the money. So there's no difference in the revenue. And how many pounds of the B grade and the A grade coffees are required. Okay, so you see, this is exactly like that interest, but just with different name. When you talk money, you call them interest. When you talk about the business, you call them price. Okay. Okay. So for example, let's see. Assume there are X pounds of B grade coffee. X pound B grade coffee. Then how many pounds of A grade coffee? 100 minus X pounds A grade coffee. Because the total, you mix them, you do not lose anything. The total is 100, so the sum of them should be 100. One is X, the other one will be 100 minus X. Okay, so let's say there's no difference in the revenue. Well, what does it mean? X pound of B grade sell for $5. So X pound times 5, this is earning. And 100 minus X pound of A grade sell for $10 per pound. This is earning. You add them together, this is total earning. When you separately sell both grade, it should be the new blend. The new blend has 100 pounds, but the price is 7. So 7 times 100. This is the revenue, this is the earning when you sell them as a blend. So there's no difference, means they equal to each other. Okay, so that's the equation. Well, let's try to solve it. 5x plus 10 times 100 is 1000 minus 10x is equal to 700. So it's 1000 minus 5x is equal to 700. So it's 300 is 5x and x is 60. Right? You move the 700 to the left side, 5x to the right side. 1000 minus 700 is 300. 300 is 5x, x is 60. So 60 pounds of B grade. So we need 60 pounds of B grade. And of course, 100 minus 60, 40 pounds of A grade in order to satisfy the requirement, right? See it? So this mixture problem is actually a variation of this investment problem. They are almost identical. Okay. Whoa. Okay. Good. Now let's move to the part 4. Part 4, the uniform motion problems. Uniform motion problem. Uniform motion problem. What is uniform motion? Like we already say that the speed is a constant, the distance and the time. The speed is distance divided by the time. In other words, if you move d to the left side, you will not d, t to the left side, you will also get distance is speed times time. Here we use r because it comes from rate. If you use speed, you can use s or you use v, velocity. It's the same thing, but here we use r to represent the speed. And this is the uniform motion formula. Okay? Uniform motion is always d equal to speed times time. Okay? Let's say Tanya. Tanya is a long distance runner. Okay? A long distance runner. She can run a long time. Okay, runs at an average speed of 8 miles per hour. Okay, so usually you know that when you run, you never keep constant speed. Sometimes you run slow, sometimes you run fast. But when we talk about average speed over this distance, the average speed is always fixed. It's always just a distance over time. So when we consider average speed, we can consider it as a uniform motion. Okay. Okay, so this is her speed is 8 miles per hour, and 2 hours. That's a general information. Then let's see the true situation. 2 hours after Tanya leaves your house, you live in your Honda, in your car. You live in your car and follow the same route. Okay. If your car has average speed, if your car's average speed is 40 miles per hour, so you drive very slow, not very slow, not fast, right? How long will it be before you catch up to Tanya? Possibly she left her cell phone in your house. You have to catch her and give the cell phone back to her. You cannot call her because she has no cell phone. All right. How far will each of you be? How far will each of you be from your home? Okay, you're talking about the distance. Okay, so let's see. Your house is here. And Tanya left your house, and then she starts to run, and 2 hours, you realize you need to catch up her, so you start to have a car. And then, when you drive the car, of course, Tanya still runs. So this moment, this hours, is a common hour for Tanya run and you drive. Okay? But in the problem, we don't know the time. They ask you how long will it be before you catch up to Tanya. Okay, now let's see, because we don't know the hours, so assume after X hours you catch up to Tanya. Okay, you catch up Tanya after X hours. Okay, now you can put X here. Then you're supposed to solve for X. You solve for X, you need an equation. And the equation means you have two parts. The left side is equal to the right side. So you have to know what is the equal quantity. You see here, for the Tanya, she runs all the time, but she runs 2 hours plus X hours. She has speed 8 miles per hour, but the total distance from your house and to the meeting point is the same distance you traveled in your car within X hours. So Tanya has speed 8 miles per hour, and she runs 2 hours plus X hours. Speed times time is the distance. And for you drive the car has a speed 40 miles per hour. You drive X hours. So that this product also gives you the distance You see here, those two distances should be equal. And this is the equation you need to solve for x. Okay, so when you correctly graph it, you will see how the equation comes up. Okay, so 8 times 2 is 16. 8 times x is x. So it's a 40x. It's equal to 40x. You move this 8x to the right side, it's 40 minus 8. It's a 32x. 32x times as 32x is equal to 16. X is 0.5, 1/2. Half hour. You drive half hour. 30 minutes, you can catch up to Tanya. Okay, so this is the time. This answer the first question. And second question, how far will each of you be from your home? So basically they ask you this distance, right? Because you catch up to Tanya. So two of you, each of you, or both of you actually at the same place at the same moment. So this distance will be the same. So this you can compute from either side. You can say, okay, the car has speed 40 and the car drives half hours, it's 20 miles. So when you catch up to Tanya, you are 20 miles away from your home. So you can answer that it takes you half hours to catch up to Tanya, and you are 20 miles from your house. 20 miles from your house. Okay? Okay, so part 5. There is it's called the constant rate job problem. Constant rate job problem. So we have a common sense. It says if a job is done in t units of time, if a job is done in t units of time, then in 1 unit of time, 1 over t of a job is done. So basically it says if you can finish your work in 2 hours, then in 1 hour you can only finish half of your work, right? Half, 1 over 2. 2 hours, 1. Then 1 hour, 1 over 2. All right? Okay, so that's the job stuff. Now let's see the exercise. Well, the exercise, this is a long problem. Trying not to copy it. Okay, let's see what the problem is. Sorry. Okay, so this is the problem. At 10 a.m., Danny is asked by his father to weed the garden. From past experience, Danny knows that it will take him 4 hours. Okay, So he needs 4 hours to finish the job, working alone, just by himself. His older brother, he has a brother, Mike. When it is his turn to do the job, requires 6 hours. Well, Mike is slow, right? Danny only needs 4 hours, but Mike needs 6 hours. And Mike wants to go golfing with Danny and has a reservation for 1 p.m. You see here, Danny needs 4 hours. 10 a.m. plus 4 hours is 2 p.m. So if Danny himself finish this job, then Danny and Mike cannot catch the reservation, right? So at 1 p.m. they have a reservation for golfing. So Mike agrees to help Danny. So those two brothers will work together, assuming no gain or loss of efficiency. They still try their best to do what they can do. When will they finish if they work together? Can they make the golf date? Okay, can they make the golf date? You can stop the pause the video and try to copy the problem. Okay, so let's check. Danny, one job, 4 hours. Mike, the same job, 6 hours. Same job, 6 hours. And now they are going to work together. They work together. One job, how many hours? We don't know. We put X hours. Okay? So let's see, assume they need X hours together to finish the job. Okay, X hours together to finish the job. Well, then one job needs X hours, one job needs 4 hours, one job needs 6 hours. Let's see, in 1 hour, the problem says no gain, no loss of efficiency, which means in 1 hour, Danny will finish 1/4 part of the job, right? No gain or loss of efficiency. So in this 1 hour, even though they work together, Danny still finish 1/4 of the job. Mike will finish 1/6 of the job. They work together in X hours. In X hours, the efficiency, like in 1 hour, in 1 hour they should do 1/X of the job. And this is equal. No gain or loss of efficiency. That's how the job done in 1 hour. Job done in 1 hour. Okay, so we're trying to solve this. We add 1/4 with 1/6. We find the common denominator 12. So this is 5/12 equal to 1/x. So you flip two sides, you will get x is 12/5. It's 12/5. 12/5 is 2.4 hours. Right? So they can finish the job in 2.4 hours. 2.4 hours. What is 2.4 hours? 1 hour is 60 minutes. 2 hours, we know what it is. The only problem is 0.4 hours. 0.4 hours. will be 0.4 times 60, 24 minutes. Okay, so this is 2 hours, 24 minutes. And they start 10 at 10 a.m. So they finish at 12 p.m. 24 minutes. 12 p.m. 24 minutes. And that is before 1 p.m. So they can catch the date. They can catch the date to play golf. Okay, so that's the last problem. Okay, so this section is very dense. Do the exercise. If you have any question, verbal question, ask me. Okay, so I'm happy to answer whatever question you ask. And okay, we finish this lecture in this video. Thank you.